Hi, this is Johnny MaK, and welcome to Live Mixing Concepts Episode 5. Today we will be talking about internal routing. In the previous episode, we covered the phase and time delays between the physical positioning of microphones and how we can help mitigate these issues. And in this episode, we will be talking about how your internal routing can create these exact same issues. Before we continue though, I want to address one of the comments that I received in the previous episode. From ihatetypinginboxes.
I would caution against using the term phase to also refer to polarity, especially in a video intended to teach the two concepts to people who may not know the difference.
Now naturally, I downvoted this comment immediately. Just kidding. He's actually totally correct here, and I didn't explain the difference in the previous episode. So let me address this before we continue. If you want to skip this explanation, feel free to jump ahead. But basically, it is the positive and negative movement of the waveform. This is very much the same as the positive and negative polarity in electrical currents, as this is exactly what a waveform represents. I'll bring up our snare drum again. The waveform moves upwards in a positive motion when it starts, and if I reverse the polarity, we flip the waveform upside down and it starts in a negative direction. A positive movement upwards would represent a positive or outward movement of a speaker, and a negative movement downwards would represent a negative or inward movement of a speaker. When we flip the polarity, this is also known as 180 degrees out of phase. If you were to compare the now flipped signal to its original self and sum them together, you would end up with silence. I explained this in the previous video, which you can see here. Now, 180 degrees out of phase doesn't really happen in the real world, because sound is constantly changing due to a variety of factors. This means that nothing is an exact copy of the original source. So phase would then be referring to all of the other degrees of phase, of which there are an infinite number of variations. As we shift the time of our frequencies, we can create cancellations in one part of the signal, but not others because different frequencies have different cycle lengths. Feel free to watch a previous episode for a deeper dive into this, and I will link the article that I Hate Typing in Boxes linked to me, as it has a great explanation in there as well. Okay, let's just have a quick brain cleanse. Here's a picture of a puppy. Now that that is out of the way, let's show how the internal routing in your mixing console can create phase issues. Everything that you do inside of your console is going to create very slight time delays. These time delays are known as latency. Latency is the computational time that it takes to complete a process, and seeing as our industry is almost now entirely digital, pretty much everything we do adds latency. In Pro Tools and every other DAW that I have used, they have rectified this time delay by adding delay compensation. Delay compensation calculates this time delay and subsequently delays all of the other channels to keep them from moving out of phase with each other. Here I have two channels that are playing the exact same drum parts. If I bring up a plugin that I know requires a lot of processing time, you can hear that nothing has audibly changed, but at the bottom of the channel, you can see the amount of samples required to keep these channels in phase with each other. However, in live audio, we aren't this lucky. Because everything is more time sensitive, we want there to be as little time delay as possible from the sound coming into the microphone and back out of the speakers. If the time delay is large enough, there will be a disconnect between what we are seeing on stage and what we are hearing. So as a result, live mixing consoles don't have this delay compensation. If I play the same section again, but with delay compensation turned off, our result is a horrible shift in phase. I'm going to show a few other ways that live mixing consoles can add latency so that you are aware of them, and then I'll break down ways that we can mitigate them. Internal routing creates latency in live mixing consoles as well. Pro Tools seemingly has no time delay that I can find, so I will recreate this latency with a sample delay. A sample is the smallest fraction of audio that your console sees. In the case of this video, these projects are running at a sample rate of 44.1 kHz, which is 44,100 samples per second. I personally use Digico consoles the most, and they have an internal routing delay of 14 samples. So I will use their internal routing delay for the sake of this video. Very often when people start using buses in their consoles, they will do so for some parallel processing. They will be sending the clean signal directly to the master channel and have a parallel bus split and added between the signal. However, before we have even applied any processing, the parallel bus now has a delay of 14 samples, and the combination of our two signals now sounds like this. This is hardly ideal. It's To get around this, we need to look at replicating the two signal chains to make sure that they have the same amount of time delay between them. If we add another bus to our unprocessed signal, we have added the same 14 sample time delay to it, and we result in keeping our signals in phase with each other. Now that we have resolved this issue, we can look at some parallel processing. Every time we add something to our signal, we may be introducing latency and a subsequent phase shift. If I add this TG12345 compressor by waves here, then we start to hear phasing again. There are a few ways around this. We could take the same approach as before and duplicate our signal to make sure that there aren't any time differences between the two. This means that we are perfectly in phase and we can set the clean signal to have no compression. But we are still adding a large time delay. In this case, we are adding 85 samples of delay, which is 1.9 milliseconds. This may not be an issue straight away, but as our mix starts to develop further, all of these additional shifts in time could cause our mix to lose power and we may lose track as to why it's happening. Waves has been good enough to give us a sheet that breaks down the amount of latency that is added for each of their plugins so that we can find a plugin that is a lot less intensive. This SSL compressor, for example, only adds 3 samples of latency at 44.1 kHz, which is only 0.06 milliseconds. If we were to use 2 of these plugins instead, we are only adding a tiny time delay as well as the added benefits of using less processing power. However, there are 2 things that you should be aware of. Most consoles, and in my specific case Digico consoles, already have processing available to you. This generally consists of an EQ section and a dynamic section, so we already have compressors that are in the signal chain. But what if you don't want to run 2 buses to balance your compressed and your uncompressed signals? What if you just want your parallel processing to run on 1 signal chain rather than 2? Well, you can. On Digico consoles, we don't have the benefits of a wet and dry signal in their dynamics processors, so you'll have to use something else. In my case, I tend to use HComp by Waves, which adds 64 samples of latency. This is definitely more than I would like, but I get the added benefits of less faders to touch and a wet and dry mix to blend between the clean signal and my compressed signal, so this is a compromise that I am happy to make. One other phase shifting process that I should make you aware of as well is your EQ. In the first episode, I mentioned that high pass filters are very important in live sound. Well, just like everything else, there is a downside to them as well. No, God! I have our pink noise routed through 2 different buses, both with an EQ section added, and then to our mix bus. This means that both of our signal paths are duplicated and perfectly in phase with each other. If I just solo one of our buses and apply an aggressive high pass filter, we can see what is happening to our signal and make a prediction about what effects it is going to have. In an ideal world, what we will achieve is a drop in level of all of the frequencies below this high pass filter. Unfortunately, because of the phase shift that is created by using a filter like this, something different actually happens. As we combine our signals, we actually get a drop in volume at the frequencies that our high pass filter sits on. So knowing this, we may end up undoing some of the work that we were achieving when we were flipping the polarity on our drums. This is why it is important to high pass first and then flip your polarity afterwards. If our EQ settings are more subtle though, the change in our signal acts a bit more like we expect it to. Though there is still a phase shift happening, personally I don't think that these more subtle phase shifts are a detriment to the mix, but if you would like to avoid this altogether, you can create a group that links the EQs together so that each channel follows any changes that you make to the other. You should consult your product manual to make sure that this is possible on the console you are using. Here is a slightly more complex routing setup. As I don't have access to a console at the moment, this is in Pro Tools, but this is still the exact same approach that I would be taking in live sound. It just looks a little bit different. My 2 kick channels are bused to my kick, my 2 snare channels are bused to a snare, my toms are bused to a toms channel, my hi-hats and overheads are bused to a cymbals channel, and there's 2 channels there which are room mics, which I just took out for the sake of this because you wouldn't have room mics up on a live situation. Then all of those buses, so the kick, the snare, the toms and the cymbals, which are all in black, are then being sent to the drum bus. So that means from the channel all the way to the drum bus, everything is hitting one bus before then as well. There's another bus that says drum effects bus, but that's just for my effects that are being run, which is a short room and a long plate, just so that I can have one fader that controls them both. In the case of a Digico console, each bus will add 14 samples of delay. So it's a total of 28 samples to get to the drum bus. And then you would have your master, your mix bus, there'll be another 14 samples of delay as well. In terms of the plugins that you can see, I just tried to stick to what most consoles would have. So at the top will be high pass filters and then gates, which you can see the previous video up here for. Then we have compression, in which case I've used the same technique that I outlined in episode 3. And then I have an EQ on everything as well, just for taste. And it all sounds like this. And for poops and laughs, let's have a listen with everything off. Thanks again for watching. This is episode 5, and I've had some great feedback on the previous 4 episodes. I very much appreciate it all. If you can remember to hit the like and subscribe button and show your support, it really helps with that YouTube algorithm stuff and gets this to a wider audience. I'll see you again next time.